Okay, so I thought we could just do some more examples. More examples. So let's
Stick the
see.
pain with tennis shoes. I didn't want to try it with.
Let's try this one.
There's a little bit.
Maybe just a warm up.
My dad left me. He's like, you need to try to stick to school tomorrow so you don't lose practice. I was like, thanks, Dad.
I remember. Is that 11x?
Yeah.
It's my dad's
Okay,
car.
sorry, I'm blind.
Oh, let's put a negative in it too.
I'm blind. I can self-identify myself as a black person.
No, you can't.
Yeah, no, at the college just said I could. I was at a college thing last night, and they said that you could.
Oh, because it's a...
Because you self-identify. Maybe I should do that.
What a joke.
I'm just saying. I thought it was a joke too, but
This
it's
is
kind of
guy
funny
at my
that they allowed you
church,
to do
Charles
that.
Quintana, who got the female Latin America scholarship because he applied for it and nobody else did. So they just gave it to him.
Oh, I guess that's okay.
Yeah. I was like, what on earth possessed you to apply for
It's
it?
really weird.
Little bit. He's really cool though.
Is he hiding?
Okay.
Either.
No.
Like in the pants or in the shirt?
He's married and has
Okay, so you know you're being recorded. Okay.
Hey, it works.
First guy. What are we gonna do?
10
Leave the 10.
over
Derivative of e to the stuff is
E to the stuff.
e to the stuff. Multiply by
Negative 11.
negative 11 because of the chain. So I end up with
negative
110.
there we go. Okay.
I like this e to the stuff rule.
Yeah, it's nice. Let's try this guy. I think I'm going to rewrite this guy first. You might not get away with it, but I think it's going to go easier if you rewrite it. How could I rewrite it?
E to the 3x to the negative 1. Negative 3x to the negative 1.
Negative 1 exponent on that x.
How did you figure that out?
Negative 3 over x.
It's divided by x. So that's the same thing as multiplying by x to the negative 1.
Oh yeah, okay.
Yep. So then if we take a derivative,
E to the stuff.
we've got e to the stuff. Nice. Times
3.
derivative of the stuff.
Times 3.
Times negative. Oh, you
Has to be
guys.
positive.
You guys are already ahead of me, so times 3
Why would it be?
X
next to negative 2, because they're bringing this
So
down
that
already, Austin.
equals e to the negative 3 over x. Or 3, I guess. X over x squared. Times e to the negative 3 over x.
Why did you put it?
Because it's x to the negative 2.
Oh, so you made it.
We good? So that one wasn't that bad. People mess this one up a lot. I remember people always messing this one up though, so be careful. Well, let's try this.
Miss B, why'd you put the 3 on the top instead of leave it on the bottom?
Because it's not negative 1.
Yeah.
Oh, okay.
Unless it had its own negative 1 superscript, it wouldn't go on the bottom. Does that make sense?
Yeah.
Negative 10
So 25 e to the negative 5x squared plus
times
10
negative 10x.
times negative 10x to the 1. Which we'd write as
Negative 250 x e to the negative 5x squared.
good. Okay.
I feel like some of us want to slow down.
My God.
I feel like we should slow down.
Times 10. Oh, that makes sense.
Okay with where the negative 10x came from?
And technically, there's a times 1 in there because you're not, but
Yep.
it doesn't really need to show up.
Don't worry about that. Let's put another couple on.
Wait, I don't.
Where you at, Austin?
Oh, never mind. No, I see. I just did it wrong.
Good?
Yeah, I think. Yeah. No. Yeah.
No, yeah, which is it?
Let's try. We did that one yesterday.
Kyle, take the lead. Just leave yourself. Tangent x.
Oh, we did this one yesterday. Oh well.
We did it yesterday. Why are we doing
We're gonna do it one more time because we're gonna finish it. I think we'll be good.
Secant x.
Okay, so if we take the derivative here,
1 over tangent x natural log of tangent x.
so if we take the derivative of any kind of log, it's always 1 over. Okay, so 1 over the stuff. Now, if it's natural log, you don't have to worry about anything else, but this is not natural log. This is log base 10, so what else needs to go down here?
A.
A natural log of 10.
Like,
Okay.
oh, it's just log. That's what.
So you just do log of 10. Or whatever a is, if that was not 10?
Yes.
Okay.
Now, if we finished,
No,
No.
there's a secant squared.
there's an inside that we need to take the chain rule of, and the derivative of that tangent is secant squared. Okay, so then we can rewrite that not too much simpler
Secant
as
squared x over tangent x natural log of 10.
So in the original Mr. Reedy, the log is the f of x, like log x is the f, and then the tangent is
it's like
the
f of g. Yes.
Yeah.
Seen it right? So there's this 1 over tangent, that's like f prime of g. Well, all that stuff is f prime of g, and there's g prime. Okay. Well, let's do this one again, but on this one, let's go ahead and make a tangent line. So let's create the tangent to g through 125. Okay?
Tar, you get the new medal of honor.
And then I'm going to show you something else on this too, something new. So something new, and then we'll do this with our calculator. Okay. So, create a tangent to g through that point, that's a 25. So we need the derivative to get the slope of that tangent line, right?
2x times natural log of 5 times 2.
So we go, okay, stuff, this isn't base e, so I need to multiply by, just kind of like on the last one.
Oh,
Wait, so how do you know
natural
it's-
log of 5, and then you have an inside, so it's times 2.
If it was just e to the x, you'd just write it down again. If it's not e, it has this scaling factor that we saw in the calculator yesterday. And then also because of that 2, we need to multiply by 2.
So if it was like x squared, then you'd multiply by 10, and then it'd still be
No,
raised to
so
the x.
in this case, e is like.
Like if it was 5 raised to the x squared.
So
okay, so
in
if
this
e
spread,
was the 2x, then it'd be different.
Right.
the derivative
5x squared
would be 5x squared.
times natural log of 5 times 2x.
Okay.
Okay.
Wait, Mr. Meady, so is the 2 in the x, that's
That's g prime.
That's-
This is f prime of g.
okay.
There's g. These parts are the f prime. There's g, and then there's g prime.
Okay.
Okay.
Why do you write down
This over here, as Brett asked. He said, "What if that happens?" Okay. So, are we done?
No.
No,
What do I
you
need to do
find
now?
tangent
Kyle,
line.
can you help me? If I want the tangent line.
I know.
You know. What do I do next? Stop it.
Well, do we need to divide the 2 by the 5 and 2x?
I want to
Is
do
it
g
wrong?
prime of 1,
I wasn't afraid that one.
as Caitlin said.
I'll be quiet now.
Oh yeah, I should do that right.
Okay. 5 squared times, this is all just numbers, isn't it? Those are all constants. So I get 25 times 2 is, okay. So there's my slope of my line. We could turn it into a decimal, sure.
Just leave it though.
I'm just gonna leave it. So let's go y minus y1, m x minus x1. So y minus, by the way, would this just work with any old point?
No. You gotta think about it.
Why would number. This is not a, this is a constant, right?
5.
Right.
So we've got 50 ln of 5. We got
X.
that times x. There's our slope, right? We said that was the slope.
And then minus that.
Minus 50
Yeah.
and then
Natural log.
plus 25. Thank you, Allison. So I get
What happened in
y.
natural
What?
log?
Natural log of 5,
50
Mr. McGee. Natural log of 5.
Do
Plus
I?
25.
What am I missing? What are they saying?
Natural log of 5.
I need to distribute that there. You're right.
Yeah, so you just put natural log of 50. It's 5.
Okay. So that's all one number. Let's just like put it in one big
Parentheses.
parentheses. So natural log of 5 minus 50.
What are you doing?
Minus 25.
Thank you. I don't know what I'm doing. Thank you for keeping me honest. So slope, intercept. Now, do you think that using like Descartes' method of circles, that Descartes could have ever possibly come up with a tangent line using just circles with this particular curve? I'm thinking that that would have been pretty impossible. I may be wrong, maybe he was able to do it. But how would he have somehow figured out that there's a natural log in that slope? I think it would have been really difficult. He might have got close, but I don't think he'd ever get
You
right
never
there.
get the exact.
But I think this is exact. Let's look at it on a calculator. And then we're going to do one little tiny
He was
thing.
ridiculously brilliant, so.
He was, so I'm not going to, I don't know everything Descartes did.
You moved your projector.
I know that he was
Yeah, but
messed with the evil genius.
Yeah, I didn't.
darn evil genius.
The evil genius always messed with the card.
Okay, so I'm going to put g in, so 5 raised to the 2x. And then we're going to put our tangent line in. So 50 ln of 5 times x plus, be real careful with this, negative 50, oh I guess it's not mid, ln of 5 plus 25. Am I good? Sub 6?
Maybe a zoom.
I can't see very good. Which way? I'm gonna go. I'm gonna shrink the X window down and maybe look up here.
Yes.
125 is way up
That's
there,
gotta be-
right? Yeah, Allison.
Okay, so when you rewrote it, you put plus on the outside. Would that make it minus 25?
No.
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 You've still just think about what objects you've really got. You've really got a plus 25 here and a plus 25 here. So at the end of the day, it needs to be a positive. If you made this minus, then it's a negative.
Then you'd have to have a negative
Does that make
outside of
sense?
there and no negative in front of it.
You can collect your terms together however you wanted. Like I just did this so we can put it in the calculator this time. That's a nice way to collect the terms. But. Okay, so I'm gonna mess with my window. I'm gonna make the y's go a lot higher, at least to 25. What do you guys think? 30?
30.
Yeah, give it some space. And I don't think we need to see all that. Maybe just 10 to 30 or something. Okay. Yeah, maybe go 5 by 5s or something. And I was gonna shrink this down and just try that. Maybe it won't work. Let's just try it. There's the function. It's looking good, it's looking right, but I'm still gonna shrink this down more so we can see it better. So I'm gonna say instead of 10 to 30, let's go get closer to 25. How about 22 to 27, and I'm gonna shrink this down even more. I'm gonna go from 0 to 2. Oh. Yeah, maybe make that window a little wider. Just trying to get a nice picture. Just play it around. So did wider work?
Not really.
No. So narrower.
Maybe though a little
What do you
bit
guys think?
more wide so you can see it leading again.
Sure. A little bit more Y, you're saying?
Yeah, like raise the Y max.
Okay, to what?
35. And do you want to be counting by 5s necessarily?
That's what you want to see. I'm still not seeing it. I think
I
that choice I made.
did it to 50.
Did it
like-
work? Look better?
My window is this.
Does it look better?
Yeah, and it looks like.
So you went to 50? What's your X values?
The min is 0, the
Uh-huh.
max is 5, and the scale is 0.5.
Okay. That looks a little better. We can all see that this tangent line's working, right?
Yeah.
If we calculate that actual value at 1, we can see that it's exactly tangent right there. So I'm going to go to 20.
You heard.
I'm just playing around though. You guys don't have to do this. There we go.
It's
That's
not
better.
real, so
Here you knew exactly what I
What?
the
wanted.
force.
Didn't you?
The force
Well, no, I have something written down on paper.
Still isn't real.
Anyway, you guys can see it looks like, does it look like it's going to be exact?
Yes.
I think it's exactly tangent at just that one spot. Okay? Now, I want to ask, what if I need to create a normal line? So I think a couple of your problems might mention this. This is used a lot for different
What?
things.
What do you mean a normal line?
Exactly, what do I mean? So, what is a normal line?
Y equals mx plus b normal? Because isn't that technically a normal line? Just
Sometimes tangent lines produce things in physics and other applications. Sometimes you need a normal line, it turns out. So a normal line on this picture is going to look at that spot. I guess this is about where 125 is. A normal line is not going to be tangent to the curve. It's going to be exactly perpendicular to the curve. That's what normal means. Normal means
so do you
perpendicular.
find the tangent line and then find the perpendicular line?
I'd find the tangent line, we've got it, right? So what is the perpendicular line? We'll say this is y tan.
1
What
over
is y norm?
negative 1 over 50 ln.
So
What's
the
the
normal?
normal?
So the normal line's the perpendicular line. at that
Perpendicular
point.
line, right? So I think the slope of it is going to be, you guys were reciprocaling this,
Flip and
right?
negate it, right?
Negate and flip, so it's negative 1 over 50 ln of 5 times x. There's its slope. Can you just leave this alone?
No.
No, you gotta plug it in.
I think you need to fix it again, so we'd have to go y minus 25, x minus 1, and redo that. Times x, then we've got a plus 1 over 50 ln. I always want to write ln as h.
It's not h.
Anybody else have that issue?
Not really.
Just me.
I keep on putting an I between the two though, so I don't know why I'm doing it, but I do.
Okay,
Me. I do it.
that's my new y-intercept. Let's see if it looks right on the graph. Let's see if it traces about where my guy was. Let's see if that's the normal line. So I'm going to make the normal line bold. Times x plus, I've got plus 25, right?
Yeah, plus
And then I'm also going to go plus 1 divided by
50 natural log
50
5.
ln.
He already has 20.
It doesn't look very perpendicular to me.
Slope looks like it's 0.
I'm wondering if I need an extra set of parentheses right here.
Or did you
No,
multiply
no,
by
I
x?
think that would make sense, Miss Reese.
Did you multiply by x?
I think I did. Let's see if that fixed it. Yeah, I put an x in there. Maybe I deleted it. Why is Todd saying I multiplied by x?
Because that's your slope.
Because that looks like it's constant, it's
And
flat.
it should not.
It's a good thing to check. So maybe I didn't, maybe I deleted it.
So it should be what's on the board, right?
Yep.
1 over 50.
Theoretically, that is correct. You know what? Times
X.
x plus 3.
Maybe you should take the plus 25
Or
out.
the x in parentheses would be a
Yeah.
slope.
You should use that alpha F1 option.
I did that and it looks like that. I
You don't have
did.
an
Oh, it looks the same way?
Huh?
No.
Maybe we did something wrong. Reciprocal, yep.
X plus 1 over 50.
Shouldn't it be a negative 50
No,
out
it
of
should be
5x?
plus 25 and it should
Oh,
be
no, wait, never mind.
plus
You have
1
that
over
too.
50 natural log of.
Let me look at it. I'll figure out our problem. Alright, you guys have the rest of the hour. So.
Diagrams.